All right, so if possible, evaluate discovery here. And my suspicion, if they're saying if it's possible, it's probably related to something that I do know, like telescoping series or the geometric. So I'm going to look at it, and I'm going to look at the geometric first, by the way. And the geometric series, you know, you get 1, let's see, 1 minus x would equal 1 plus x, I'm sorry, let me erase that. I spoke, but I wrote something different. So 1, it's plus x squared, plus yada, yada, yada. And this is going to be true provided the x, absolute value of x less than 1. So I'm really not seeing that, but I'm seeing something close to it. And what I'm going to do is I'm going to differentiate. So let me write this over here. So I'm going to differentiate 1 minus x to the minus 1, and this is going to be 1 plus x squared plus yada, yada, yada. So if you differentiate, what do you get? You can get, let's see, minus 1 minus x to the minus 2, and then you take the derivative inside, which is minus 1, so this is going to be plus now. And what do you have here? You're going to get, let's see, 1 plus 2x plus 3x squared plus 4x cubed plus yada, yada, yada. So I think I'm seeing something here. I'll write this one over here for you. I'm seeing 1 over 1 minus x quantity squared. And I gotta, sort of like write this down as a sum now. And I'm hoping I'm going to see it over here. So let's write this down. And, maybe I don't see it. But I'm seeing this, I'm going to put n equals 1 off to infinity. And I'm going to say n. I definitely see that. I see 1, 2, 3, blah, blah, blah. And then what do I see? I see x. If I were to write that down, let's see. It would look like n minus 1. All right, I'll put this over here. Let me see if that's true, by the way. You get, that would be, there would be no x, then 1x, and 2. Yeah, it looks pretty good. All right, so I'm looking at this one over here, and, I got the sum, I got this written down, and I think I have that pattern to it. And the question is, can I do that over there? And, yeah, I guess we can. Right, I guess we can. And someone says, what do you mean you guess you can? I'm going to look at this over here and realize that I think I have it almost, but I got to select an x now that works, all right? So I'm going to look at it, and I'm not really quite clear about it. I'm going to say x equals 1/2. Let me see if that does it for me. All right, so if I were to write that down, what would I get? I'd get n equals 1 off to infinity, and that's going to be n. And if I put down 1/2, what am I going to get? Well, I'm going to get here, I'll get 2 to the n minus 1. All right? Now, does that give me the series they want? And I don't think so. So there's a problem here, isn't there? And my question is, what's the problem here? This would be equal to 1 over 1 minus 1/2 quantity squared. And it's not exactly what I wanted, but it's pretty close. So this gives me 4. I'll tell you what that is. The bottom is just a half. And a half squared is 1/4, and 1 divided by 1/4 is 4. But this one, I got to make it look exactly like this one over here. So n equals 1 off to infinity, and it's going to be n. And I'm going to write 2 to the n. Now, I got to pull a 2 to the minus 1 out, which is going to be a 2 over here. All right? So it's going to be 2 equals the sum, n equals 1 to infinity, n over 2n. Now, is that what they have written over here? It certainly is. We're good to go. What's the sum equal to? The number 2. Thank you.